going to be a review for post-test Unit 2. The very first thing that we are going to talk about is the unit circle. Now, the goal of this lesson is to be able to convert degrees to radians. So a degree would be something like, 30 degrees turns into pi over 6. And we are also going to apply the Pythagorean identity. Oops, and that's something that we're going to talk about at the end. What you need to know ahead of time to be ready for this lesson is trigonometric ratios. And let me show you how that looks like. This is something from geometry. We have the sine is the opposite over the hypotenuse. The adjacent over the hypotenuse is cosine, and then a tangent is the opposite over the adjacent. Now, you do not really need to do these calculations in this lesson, but having a background knowledge of that will help you understand parts of the unit circle. Now, something that I really want to point out, if you want to prepare for the post-test, please see the tutorial examples and exercises. I was looking through the lesson, and these are actually more like the post-test than your actual post-test practice. So what we're going to do today, we're going to take some problems from the tutorials, maybe make some of them up that are more similar to your post-test. Okay. Any questions so far? If you have any questions, please type in the chat. Good. Okay, so let's begin. One of the questions that you're going to have is the point negative square root of 3 comma y lies on the unit circle. What is the value for y? And you're going to have four options to choose from. I just picked 3. For your post-test, you want to make sure that you have a picture of the unit circle for reference. For this one, all you have to do, you look at the x values of each part of the unit circle. Here you have negative 3 over 2, and then negative 3 over 2 for the x is right here. So this is one of the points. And you're actually going to have that value again right here. Then from looking at the chart, you just look at the options that you're given. And in this case, we notice that 1/2 is not there, but negative 1/2 is here. So we will select B. Now again, just make sure you have a chart or a picture of the unit circle with you. We'll probably add it to the website at the end of this lesson, or just send it by email. Yeah, you want to make sure that you have that ready, because they'll just ask you a question and you're supposed to have this for reference. Okay, any questions? Good. All right, let's go to number 2. Okay, this is kind of a tricky one. It says angle theta. Theta is just a Greek letter. It means angle. Angle theta lies on the 4th quadrant. And cosine of theta is equal to 4 over 5. Okay, and you need to give us the sine theta of that angle and the tangent. Now, what does that even mean? Okay, so on the unit circle, you are going to have an angle, and it's going to be on the 4th quadrant. It's going to be right here. Oops. 4th quadrant. What does that mean? On the 4th quadrant, the x's are going to be positive, but the y values are going to be negative. And it's going on the lesson. They tell you that x is the same as the cosine of the function, and then y is the same thing as the sine. If you have any more questions about this, please let us know. We'll make extra time, maybe another day, to go over this. But this is just basically using trigonometric ratios, or SOHCAHTOA, to conclude that x is the same as cosine of an angle, and then the y is the same as the sine of an angle. Okay, so what this tells us is that whatever we get for sine has to be negative. That's the very first thing. Okay, and now to figure out what the sine is, we're going to apply this formula here, and this is a Pythagorean identity. Okay, so let's go ahead and solve for sine. So we have cosine squared theta, which is the same thing as 4 over 5 squared, plus sine squared theta equals 1. Now what I'm going to do, I'm going to square each part of a fraction. This is going to be 16 over 25 plus sine squared theta equals, and instead of just writing it 1 like this, I'm going to write it as 25 over 25, which is the same thing as 1, but I just want to make sure that my denominators right here are the same. Because then I am going to subtract 16 over 25 minus 16 over 25 to both sides. It's easier to subtract when you have the same denominator. Now this is the same thing as sine squared theta equals 9 over 25. Okay, now, but I'm not done yet because I need to get rid of that squared. To get rid of the square, I need to take the square root of everything here. Now this is going to leave me with sine theta is equal to 3 over 25. Any questions on how I went from any of these steps, the square root, canceling the square, leaving sine by itself, any of these other steps? If you have a question, please type it in the chat, and then if we need to stop, Ms. Perez will let me know. Okay, so our answer is 3 over 25, but we already said that if it's in the fourth quadrant, that white point has to be negative. So our answer is going to be negative 3 over 25. Oh, great question. Why isn't the 25 square rooted? Because I forgot. Thank you for catching that. Oh, thank you. All right, it's just another way to, just remember to be careful. You might be doing all the steps correctly, but then you say 5 and then your hand goes like, 25. But yeah, thank you for noticing. Okay, perfect. All right, so that's sine, and then tangent. How do we find tangent there if that's not even part of a formula? To find the tangent of an angle, this is another thing that you need to remember from geometry, and I'm not entirely sure they go over it in the tutorial, but tangent is the same thing as the sine of an angle divided by the cosine of an angle. So what I'm going to do, I'm going to get my value for sine, which is negative 3 over 5, and I'm going to divide it by the cosine, which is the value that they already give me. Okay, now to divide two fractions, I'm going to bring down my first fraction. I'm going to turn this into a multiplication by multiplying this by the reciprocal. The reciprocal of a fraction is just the same fraction but switched. The numerator becomes a denominator and the denominator becomes a numerator. Okay, and then we just multiply across. Negative 3 times 15 times 5, is negative 15. 5 times 4 is 20. If you reduce this fraction, this is both divisible by 5. Your final fraction will be negative 3 over 4. That is your answer for tangent theta. Any questions about this? Okay, perfect. And just make sure that you write this formula down. You will use it on the post test. Okay, let's move on to what I believe is the last question on the unit circle. Okay, so the measure of theta, and it's just a symbol used for an angle, is 9 pi over 4. What is the measure of the reference angle? Oh, okay. Now uh, let me input an image that I'm going to use. Okay, reference angle, and this is pretty much the first lesson on the unit circle. Every I'm gonna pick the 45-degree angle. 45, and then this guy, it's cuts it right in the middle. It cuts the other quadrant right in the middle. It cuts this one right in the middle. It's right in the middle. Now all of these are multiples of 45. The reference angle for this is 45 degrees. Just think about what is like the starting angle in a way. So that's pretty much the reference angle, and for that you're only gonna use this quadrant. So for example, if they give you, I don't know, the angle is 225 degrees, what is the reference angle? What type of angle is it? It's an angle that's a multiple of 45. That's what they mean um, by the reference angle. Do you have any questions about what the reference angle is at the moment? Okay, perfect. All right, now let's try to figure out what is 9 pi over 4 as um, an angle. Okay, so let's figure it out. Oh, okay. I'm going to go here because I'm running out of space. Your tutorial mentions that pi radians is equal to 180 degrees. So 180 degrees, that's half of the circle. From here to here, that's pi. And then a whole revolution is 2 pi. So that's something that they give you. Now, what is that in angles? What is 9 pi over 4 in angles? Oops. All right, so what you're going to do, you're going to form equivalent ratios. You're going to take the formula that they give you. I'm not going to include the word radians. I'll just write pi is equal to 180. And I'm going to include the radians that they give me, which is 9 over 4 pi. And I don't know what that is in degrees. I don't know what that is, so I'm just going to call it x. To figure out that angle, then we're going to cross multiply. Okay, now we have pi times x is pi x, and then that's going to be equal to 9 over 4 times 180 times pi. Okay, so what I'm going to do here, I'm going to divide by pi just to get rid of that pi. So at the end, our final answer in degrees does not have to have pi. And then x is equal to, and I'm just going to do this on the calculator, 9 times 180 divided by 4 gives us a total in of 405 degrees. Okay, so 405 degrees. Now, what type of angle is this? Is this a 30-degree angle? Is this a 60-degree angle? Is this a 45-degree angle? If I divide this by any of these, that's how I'm able to find out. So the reference angle for this one is actually 45 degrees. It's like the starting angle. And I got this by dividing 405 by either one of those. Another way to tell if this is what the reference angle is by looking at the radians. Let's go back to the unit circle. The measure of angle theta is 9 pi over 4. The only angles in radians that are divisible by 4 are the 45-degree angle ones. You got pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So on your post-its, you're going to have a question like this, and where you have to convert from radians to degrees, and then you have to match it to a value on the unit circle. Sometimes you will be able to tell just by looking at the unit circle without doing any of the conversions. If it's the denominator is 3, it's going to be a 6-degree angle. If the denominator is 6, the reference angle is going to be 30 degrees. But if they give you something weird and funky and you don't know what it is, convert the angle into from radians to degrees and then divide it by one of these angles. Or if you get one of those matching questions and they give you another angle like, I don't know, 52 or something, then divide it by that. See if you get a whole number. Now, when I went a little bit fast on this part, is everybody okay with this? Oh, then let's see the tutorial. Let me go to tutorial. To understand this, please go over pages 22. Let me see if I can skip there. Oh yeah, 20 and 22. 21, they talk about the reference angle. 22, 22, 23. So pretty much right here, if you have any difficulties with the reference angle, just start the tutorial from here. And that's all for angles. Oh, yes. So 45, 405. Yes. Okay. So let's try like 45 when you divide 405 when you divide by 45 you get 9. Yes. So let's do that. So 405, if I divide it by 45 degrees, I get 9. Okay. Now what I mean by that is if I divide 405 by any other angle to that from the list, let's say 30. I'm going to divide it by 30. My answer is going to be 13.5. What this means is that 405 is not a multiple of 30. You can't evenly divide it by 30, so the reference angle can't be 30. Now, if I am dividing 405 by 45, I get a whole number. Now, if you get a question on the posters where you just need to find the angle, you would be done with this. But you might get several angles to choose from. Like, let's say, out of this list, which one is the reference angle? And then to figure out from there, like, let's say this would have been A, B, C, and D. you need to divide the number by all of them to see which one matches. So this is of the type of 45-degree angles. Does that make more sense? I hope. Okay, great questions. Thank you so much for participating in those. Okay, so I'm gonna get you started with the next tutorial, like the next practice questions, and then Ms. Perez is gonna finish the rest of the questions. Okay, trigonometric functions. Now the goal of this lesson is just to learn the three main trig functions: sine, cosine, and tangent. And actually, tangent is just kind of presented to you. You don't really do much with it. And you're gonna learn what their graphs look like and their key features, like amplitude and the period. Now, something that you should already know is how to transform functions, like the vertical shift. What else? The horizontal shift. And also, you need to have access to a graphing calculator like Desmos or GeoGebra. Okay, so let's say, remember this chart from last time? Last time we only went over these parent functions. Now we're going to focus on these right here, sine and cosine. Oops. All right, and then they give us this formula. F of x equals a sine bx plus c plus d. What does that mean? So what I'm going to go right now, I'm going to go on Desmos. And I highly encourage you to use this calculator when you are transforming sine, cosine, and tangent. Okay, so this was y equals a sine bx minus c plus d. Now, when you give Desmos a letter that is not x or y, it's going to create these letters right here. Now, if you look at the a, the first number in the front stretches it or compresses it. And then Ms. Perez is going to go over those more in depth. Is that correct, Ms. Perez? Now, B is the horizontal stretch. So you're stretching it like sideways. Sideways stretch, stretch up and down. Okay, I'm going to put it equal to 1. Now, C is the horizontal shift. On this tutorial, it's not called the horizontal shift. It's called the phase shift. Same thing, it's just has a different name. So it goes by that. And then D, any number that's outside of the parentheses, outside of the X, is going to be the vertical transformation, a vertical move. Okay. All right, so let's look at a question right here. Let's say you get a question like this. What two functions show a phase shift pi units to the right? Okay. All right, let's. All right, the first thing that I'm going to do, I'm going to go to settings. And where you have the x-axis, step tells you by how much you're going to change your graph by. So I'm going to change this to pi. Now, if you notice, now the x-axis has pi, 2 pi, 3 pi. Maybe I'll do it pi over 2. Okay, now let's try to figure this out. I'm going to turn this one off. And I'm going to have my parent function. My parent function is sine x. And then I have another parent function called cosine x. And a parent function is just a function before any of those transformations. Okay, now I'm going to look at this. Cosine x plus pi. Does that indicate that you move it to the right? Now there's two ways to tell, one with the formula, but right now I'm going to just use Desmos to check. So I'm going to see. Y equals cosine x plus pi. I'm going to turn off the sign one because I want to compare this and this. Okay, so if I start here, and let's see how much it moved to the right. Okay, it looks like it went to the right by pi. So this is a maybe. This is a maybe. All right, sine pi. If you put sine pi on the calculator, it's not even going to give you a graph because pi is the number. It's just going to give you its value. So that's an automatic no-no. Now I have cosine of x minus pi. Okay. And the interesting thing is that this one matches the one that I had at the beginning, the plus pi and minus pi. Okay, so that's a maybe. And then the last one is 2 cosine parentheses x minus pi. Okay, now the amplitude, or how big it is different. Like how wide it, not wide, how tall it is different. But if you notice, it's also right here at pi. All right, so now, if decimals does not help you with that, now we gotta look at the formula. Where is my function transformation formula? Oh, there we go. Okay, now we are interested in the horizontal shift, which is the same thing as the phase shift. Okay, and we are moving to the right. When you move to the right, you have a negative inside the parentheses. So A is automatically out. Now on the graph of decimals, it looks the same because this one actually moved to the left the same amount of units. Now in this one, you need to look at the rules. Okay, so what two functions? So it has to be C and D because both of these have a minus pi. Now this is a little bit different. You have a 2 in the front, but right now they're just asking about the phase shift. They're not asking about anything else. As long as you have x and then a minus to indicate that it moves to the right, and then the bound that they're asking, that's all you need. Okay, does anybody have any questions? Now, if you have any other questions about what is a function transformation, what is decimals, I never used this before, please let Ms. Perez or myself know, and we can schedule a separate time to go over more details of these questions. But yeah, so I guess that's it for my part. Now, Ms. Perez is gonna go over more in depth with these and finish off the lesson. Okay, let me stop this.
Okay, so we are starting with, let's see. Oh, yes. Okay, so let me put in some things. I'm going to do another question from the same tile, graphing trigonometric functions. So for this tile, we're only going to go over 2 questions instead of 4. So this one has to do with, let me find this. So pretty similar to what Ms. Kajanis had up. There it is. Let me know if this is too small. I can enlarge it. But we're going to be using this. Okay, so this is going to be good for if you have a question that's similar to this, what transformations are happening, or let me look at the exact wording. What's going to be good in your notes is having the correct directions in your notes, so you can compare them and go, okay, this is the kind of question that they went over in the review. I can match it to my post test, and these are the steps I need to take. So the question is, what transformations? Let me rewrite this so you guys have it exact. Which transformation causes the described change in the graph? Okay. And again, if this is too tiny, just let me know. I know that was a problem last time. Okay, and then you might have something, a couple options like this. So we might have, cosine of 2x, negative 2 cosine x, cosine mm, cosine x over 2, stuff like that. So, and they want to know kind of what's happening. Let me move these over here. Okay, and we're going to use this chart, and I'm going to use GeoGebra too to kind of figure that out. So we want to know, okay, cosine 2x, what's happening to it, and we have to use the correct verbiage because that's what's on your post test. Is these, is it stretched vertically? Is it compressed vertically? If you're good at using this chart, then use it. If you don't need GeoGebra, then you're fine with this. You can compare what numbers are being used here. Then just use this chart. I'm gonna add GeoGebra to it. So first, I'm just gonna go geogebra.com. I'm gonna go to the classic, wherever that is.
On top of the. Oh.
There we go. Okay. So first I'm just gonna, same thing, I'm gonna get my parent function out there so I can kind of see what that looks like. Cosine x, and there it is. Okay. Next one I'm gonna do is I'm gonna type in that function that it gave, that I made up, this cosine 2x. Cosine 2x. Oops, I'm messing that up. Oops, hold on. Cosine 2x. There we go. Okay, so now if we look at just our parent function, and then we kind of compare the transformation that happened just by looking at it. So what happened to these waves from the green waves to the red waves? Did it, and kind of, again, if this is too tiny, let me know. I will try to just flip it back and forth. But look at these. Look at the vocabulary that's being used. Is it stretched vertically? Is it compressed vertically? Is the transformation that's happening even vertical, or is it horizontal? So this is just a piece, if you're more of a visual learner, if you want to be able to see this transformation, go on Desmos, go on GeoGebra, graph these, and then you can kind of visually check out what's happening here. So if you look at it, it's kind of being the transformation that's happening is horizontal, right? Nothing is happening up and down. It's not getting taller or shorter up and down. So nothing's happening vertically right now. So what's happening is, horizontally, it's, this way, back and forth. So, and then we can kind of compare it to what we have on our chart here. So right here, we can see that if there is a number that is greater than 1, being multiplied by our x, by our function on the inside of the parentheses, it's compressed horizontally. So again, you can visually see what's happening, or you can compare it to this chart. So we're gonna say compress horizontally. One thing I will add that to your answer. So compress horizontally. This word is interchangeably, right? Compress. This is also another word that can be used as shrink. So if you want to maybe have this in your notes, right here, kind of write the word shrink next to it. They do use that word in your tutorials and mastery tests a lot. Shrink, shrink. Okay. Um, so that would be this one. Okay, so now we're moving on to the next one where we have a -2 on the outside. So again, let's just graph it. We can kind of see what it looks like. I'm going to delete this one since we don't need it anymore. So we have a negative. I'm just going to do positive. I'm just going to do +2 cosine x and see what that looks like. And let me change it here so we don't get confused. Okay. Okay, so again, let's check this out. Here's our parent function, what it looks like, and then our transformed function. Now you can see here that it's getting taller, right? It got taller, so the transformation now is happening vertically, right? It's happening up and down vertically. It's a vertical transformation. So you can kind of eliminate some of these, by just saying, okay, it's not a horizontal transformation, it's a vertical transformation. So now I just have to decide, okay, is it this one or this one? We go back here, we can kind of look at it, or we can compare the chart, right? Where's my number? Where am I being where am I multiplying this number by? Well, I'm multiplying a whole number, so that's this one. A whole number, it's greater than 1 on the outside of the parenthesis, right? The number's being multiplied by the outside of the parenthesis, this a. So and this checks out vertically. We know our transformation is vertical, right? So it's being stretched vertically. So I, again, suggest you figure out which method is best for you. If you're a visual person that needs to see that trend, decide, okay, is it vertical or horizontal? Use Desmos or GeoGebra, and then, or if you like the chart, knowing, okay, where is my constant being multiplied inside the parentheses, outside the parentheses? Is it a fraction? Is it a whole number? Then use the chart, or use both. So yeah, vertical, we said stretch. I really like the chart because even I get, I sometimes my eyes plays tricks on me, but I think both resources are great. Okay, last one, cosine of x over 2. Let's go ahead and delete this one. Cosine of x over 2. All right. Okay, so again, we're just going to look at our parent function right here, and then we're going to look at the transformed function. So we can kind of see that it really doesn't change, height vertically. So this is probably, it changed horizontally, right? The waves are a lot spread out, right? So immediately I'm going to go, here and be like, okay, I'm going to cross out all the, eliminate all the vertical options because I know it happens horizontally this ways. Okay, so here's where I'm going to look at these two and decide, okay, is it does it compress or stretch? Well, I know I'm multiplying a fraction on the inside of the parentheses. So that's this one. Here's my fraction. It says a fraction, and it's being multiplied on inside the parentheses. So I got stretched horizontally, and it kind of looks like that, right? If you took the original parent function and you say this was a string and you grabbed this piece of string and you stretched it, you started pulling on it, it would probably look like that. Maybe not a string, maybe like a piece of wire or something, curved wire. Anyway, so this one is a stretch horizontally. Okay. And that's pretty much one of your questions on your post test, is just being able to identify what kind of transformation is happening based on where this, what kind of number is being multiplied by your function and where, inside the parentheses, outside the parentheses. So this chart is, again, really, really useful. Thank you, Ms. Kajanis, for creating it for us. It definitely helps me out tons. So that's the last question we're going to go over for graphing trigonometric functions. I know Ms. Janice has been answering some questions on the chat, but I'll pause for a second to let anybody else ask some questions regarding this type of question. Okay, we are good to go. So we're going to move on to the next tile called interpreting trigonometric functions. So it's the last tile in Unit 3. All right, so let me get all set up there. Okay. So I think I have 3 questions ready for you guys and some practice. So we have about, we're supposed to be done in 10 minutes. I'll try to get through these quickly. So this is the first type of question. The period of y equals 3, cosine x is graphed. So, and you really need to know your vocabulary for this, knowing what a period is. This is one period. This is not the whole function. This is just one period. So it's asking, what is the domain of y equals 3 cosine x? So let me put in some things you're going to need. We can email these things to you afterward, but you really need to have this in your notes and this. Okay. I think that's it, right? Yeah. Okay. Let me see. Let me send Miss Kajanis these real quick. Okay. So, all right, let me move this over. All right, so some of this is vocabulary that you're really going to need to know. Okay, so let's first go over a period. You really should have that down by now, but anyway, this is a period where a function starts repeating itself, right? So we started off at this maybe midline, and this is a period. It takes us up, down, and stops here. Because this is where we're repeating ourselves. So this is one period. There's a couple different terms that they use for that. Let's see. I think I wrote them down. I was hoping I wrote them down. I might have it on a different sheet. It could be period. It could be cycle. I'm pretty sure on the other questions I mentioned the different. Oh, here we go. This is what I was talking about. In your post test, they refer to one period or one cycle as an oscillation. Okay, hopefully I'm saying that right. So just note that when they're talking about it. Okay, so now let's go over domain. What is the domain of y equals 3 cosine of x? This is a pretty easy question as long as you know your vocabulary. So domain refers to what? The x or the y values. So the domain refers to our x values or our x-axis. So here, what values does our function include? Now, what's going to trip you up is that it says this is one period. So this is not the full function. It's just showing you, okay, this is how long it takes us to repeat. Okay. Now our function goes on for how long? Forever, right? In either direction. So you might want to say, oh, the domain is from 0 to 2 pi. No, that's your period. That's the domain of the period. So really our domain is from negative infinity to infinity because this goes on forever and ever. They're just showing you one period. Now this question is almost designed to trick you, unfortunately. So just kind of know your vocabulary and really pay attention to what it's asking. So domain negative infinity to infinity. What you need to get out of this, because the question's not exactly the same on the post test, is know what domain and range are. Okay, you really need to know what that is. So if, for instance, if the question was, what is the range of this? Well, our range, you need to know, attains to the y values. What y values are included in this set? Well, my function goes up to 3. Let me erase some of this scribbling. So our function goes up to 3 and it goes down to -3. So your answer would be, the range would be from -3 to 3, right? And it's included. So it'd be that. All right, so what I need you to take out of this is knowing what domain and range are. If you're still not sure what it is, please ask Ms. Kajanis, and she'll help clarify that, or I'll reiterate it. But that's what you need to take out of this question. Okay. And of course, what a period is. Let me get rid of this. I'm going to try and get through this fairly quickly so all of you can move on with your day. Ms. Kajanis, is there any questions I need to address? Okay. All right. So question 2. If it's too tiny, let me know. Oh, nope. Okay, so the height of a person on a Ferris wheel at the Mason County Fair in feet from the ground, t seconds into the red, can be modeled by the following. Okay, it's a long sentence. I'm going to reread it because sometimes I forget what I'm reading. So the height of a person on a Ferris wheel is given in feet right here. So this is on a Ferris wheel, right? On a Ferris wheel, so it's a lot of times it's good to visualize what the heck they're talking about. So we have a Ferris wheel, right? You're going up, and then you're down, and then up, and then down, up and down. So that's where this up and down comes from, is because on a Ferris wheel, that's what you're doing. So it's showing you the motion of it. Okay, so let's get into the question. How do I delete that? Oh well. There we go. Okay, the height of a person on a Ferris wheel at the county fair, t seconds into the ride, can be modeled by the following table. So these are two separate situations. Take note of that. This is at the Mason County Fair. Oh, good gracious. Okay, Mason County Fair versus the other county fair. So these are two different situations. Which Ferris wheel takes a longer amount of time to complete one full revolution? Oh, here's another word for what? Full revolution. So where a lot of students trip up is the vocabulary. So it's not even the Algebra 2 part, just knowing the vocabulary. So what are they asking for? Which Ferris wheel has the longer period, right? So let's get into where we find that in each one, because they're represented differently. Well, if we look at this part, the way this one's looking, I'm going to use a red for this one. A period, is one full, actually exactly what they use, one full revolution from one point to another where it starts and begins. So you could pick anywhere on this graph. I'm just going to pick here where it starts on the y-axis, right? And let's see how long does it take us to get from one point to another. So it starts at, it looks like, 0.5. And where does it reach on the y-axis? And where does it reach there again? Well, it reaches there at, let's say, actually, let's figure out what our, I'm going to increase this a little bit so you guys can see. But anyway, we got to figure out what our intervals are. Our interval. So it goes up to 20. Now, does it go by ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, it doesn't go by ones. So you need to really pay attention to what intervals they're using. So it goes by, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So it goes by twos. So this is 2, 4, 6, 8. So for one full revolution, it takes 8, right? So period equals 8. Now I've used a lot of colors here. I'm sorry, I was trying to stick to one. It didn't really work out. But our period's 8 for this fair, this county fair. Okay, so now let's look at this table. It's represented differently, right? It's not represented as a graph that you can kind of find by, finding the start and stop position. We were using a table. So what did we look for? We looked for what repeats. It started at 0.5. Our y value started at 0.5, and we went all the way until we reached 0.5 again. So we're looking for the same y value. Where does our y value repeat itself to make one period? And I'm going to take a second to pause there. Does anyone have any questions about why I'm looking for a repeating y value to find the period? Okay. All right. So in this type of question that you do have in your post test, and you're comparing these two, if you have a table, you are looking for a repeating y value, which is p of t, right? So we start at 2, and where it repeats itself is here, right? So our period for this one, right? 2, 4, 6, 8, 10, 12. Our period is 12 here. That's how long it takes us. So don't get confused. Yeah, we are looking for the repeating y value, but the answer is going to be this, the x, I guess. Ms. Kajan, is anybody confused on that part? The answer would be the... Okay. All right, cool. So let's look at what we got here. Which Ferris wheel takes longer? We decided it's this one, right? Because it's 12 versus 8. So this one. Cool. Going to the very last question. Just kind of a doozy. Let's see. Question 3. Well, okay. Let me make this one a little bit bigger. Okay. You know what? There's just a couple things. I'm looking at my notes real quick. There's just a couple things that I wanted to share with you guys just really, really quick before we get into the last question. Please pay attention to pages 10. Oh, okay, that's that one. 10, 11, and 12. Sorry, 10, 11, and 13. Go through this example. It's a great example for your post-test. 10, 11, 13, and 22, I think, is a lesson activity, possibly. For some reason, that's in my notes. Yeah, page 22. This lesson activity is really great if you're struggling with these pieces of the function. It kind of goes through it. So those pages are really great pages for practice. And then so that was for the last question. If you're struggling with domain, and so that these pages will be for the last question I just did. But if you're struggling with domain and range, pay attention to pages 24 and 25. So these are the kind of domain and range pages. So I just had those in my notes. Okay. I did have some practice for you guys, but I don't want to take up too much of your time, so maybe we'll send those practice problems out later, and you can work on them. And if you have trouble with them, you can contact us. But for now, let's just move on with the practice that I'm going over. So okay, let's take a look at this one. Andy made a spirometer for a physics experiment. The spirometer is designed to measure the volume of the air in a person's lungs. Andy found out when he breathes normally, he inhales about 0.5. He inhales and exhales 0.5 of a liter of air per breath. He also found that when breathing normally after exhaling, he still has 2 liters of air in his lungs. Andy recorded 15 breaths in 1 minute, starting at the beginning of an exhale. If Andy inhaled and exhaled the exact same amount in each breath, which of the following functions best models the amount of air in Andy's lungs? Okay, that's a whole lot going on in that paragraph. So what we're going to do is we're just going to break this stuff down bit by bit and kind of figure out what they're talking about. So let me get my pen. Okay, So let's first just think about the situation for a second. So it's saying if he, if he inhales, let's look at this on a graph. You know, this is x and y. If he inhales, breathe in. This is he reaches zero point 0.5 just initially, right? And then he exhales. That's another zero point 0.5. And then he inhales, exhales, inhales, exhales. So that's zero point 0.5 up and down, up and down, up and down. So that's where they're getting this period from, right? Inhaling and exhaling zero point 0.5. So that's just a visualizing the situation. But and that's this part of the information per breath. Okay, there's one. He also found that when breathing normally, after exhaling, after exhaling, he still has 2 liters of air in his lungs. So after he breathes out, he still has 2 liters. So let's figure out what that looks like on a graph. I'm going to get rid of these things until we need them. Delete and delete. Okay. Let me underline this right here. 2 liters of air in his lungs, and this is huge, starting at the beginning of an exhale. Beginning of an exhale. Okay. I'm going to rewrite my x and y. Oops. Oh, man. Y and x. Okay. All right. So if we're starting at an exhale, right? So in this one, we were breathing in, we were taking in air, and then this was breathing out. So if we're starting, he starts recording at the beginning of an exhale. So that's way up here. So we're going to start our function up here, right? He started recording at the beginning of an exhale, and we know he breathed out 0. 0.5. But when he breathes out, it says after exhaling, he still has 2 liters in his lungs. So that means after he exhales and he's starting to breathe again, this is 2 liters, right? And then he breathes in and there's 0. 0.5, and then he breathes out. So this 0. 0.5 doesn't change, but all it's telling us is that number one, when he breathes out, there's still 2 liters left. And number two, we start at the beginning of an exhale. Okay, and I'll tell you why that's important in a minute. So here's 2 liters. So if we have 0. 0.5, this is 2.5. Let me know if anybody's curious or needs to know why this is 2.5 up here, this starting point. Okay. The reason why this is really important, the beginning of an exhale, it's telling you which function to use. And I believe I wrote down the page number. It is on one of those pages that I wrote down, I gave to you. I just don't remember which one. Let's see. Okay. Oh yeah. Okay. Okay. Yeah. Thank you, Miss Kajanis. It's in your tutorial somewhere. I wish I had the exact page number, but yes, she just messaged me this. Um, where'd it go? Where'd it go? Well, I can't get your photo. Okay, here we go. Sorry to take so much time going over that part. It's probably something you guys all already know. I just want to make sure you know. So if you're beginning at a max point, that's going to be cosine. So that's a huge indicator that you're going to use cosine. A lot of test taking skills, you're just eliminating answers first. So because cosine starts at a max point, we're going to use cosine. So let's go ahead and just get rid of everything. Oh, it's all cosine. Cool. So that didn't eliminate anything. Okay. So we got it as a cosine. So let's go through another piece of information. Um, if Andy inhaled and exhaled at the exact same time each breath, which of the following functions best models the air in Andy's after he started? So that's where our 2 other pieces come in. This one. Oops. Oops. Put that right there. And put this back here. Okay, hopefully everyone can see that. Okay, so we can kind of see that we have a couple different answers. We have 0.5 in front of cosine or 0.25 in front of cosine. We just have to figure out which one is correct on that end. So what is the number in front of your function? Well, it's the amplitude. So we can kind of use this to decide, kind of eliminate answers. That's how I'm going about it. I'm going to eliminate answers. All right, so we have to find the correct amplitude to eliminate at least 2 answers. So our amplitude is the distance from the midline to our maximum point, or midline to our minimum point. So if we go back to the graph that I kind of poorly did over here, right, we're at our max point is 2.5 and our minimum is 0.2. So where would our midline be in between that? Have I got any guesses, Miss Kajanis? Where's our midline? Oh, for our amplitude, right? Yes. Yeah. Exactly. So just to break what Xavier did, he took, halfway through 2.0 and 2.5, right? And decided from here to here was 0.25. Cool. So yes, our amplitude is 0.25. Awesome. So if you have any questions on that, I can reiterate what he did. But we're going to eliminate this one because it's 0.5 and this one. So now we're left with two pieces. The next thing we kind of need to figure out, we could do one of two ways. We could figure out D, or we could figure out, or actually they have the same period, so that's not going to work. So they have the same period, so we don't need to figure out the period. That they're both the same. Let's figure out which one is correct, the 2 or the 2.5. So what is D? D is the vertical shift from the parent function. Okay. I'm going to get rid of this because we really don't need it anymore. So remember what the parent function looks like. I'm going to try and do it like that. So the midline on the parent function, you can look at a parent function that looks a lot better than this. This is cosine, just regular old cosine of x. The midline on a parent function, let me get this, is the x-axis. So the midline is the x-axis for the parent function, right? So how much did our midline move from the x-axis to what we're saying it is now? Am I saying that correctly? Let's do okay, that's not working. Okay, so for D's our vertical shift, right, from our parent function. So how much did we? Even we could take a point. We could take a point here, right? Our max point. Oops. And then versus our max point here. How much did it, or our midline? You could go through our midline too. Our midline went from 0 on our parent function, and now where is our midline now? Does that make sense? So our vertical shift, is from the parent function. Our midline, I like going midline. I like doing it from the midline. Our midline was 0, right? The x-axis, 0. And now our midline is where? For Yeah, exactly. So our midline's 2.25. So that is our, oops, not 2.5. That is our, sorry to, I think I was saying a little funky. But our midline's at 2.25. So that's our vertical shift. That's how much we moved up, right? We got a fixed point and then we see where how much it went up, which is 2.25. So that's this one. So notice I didn't find all the pieces. I didn't go through, making sure there wasn't a horizontal shift, a vertical. I kind of looked at the answers and decided, okay, how can I start eliminating answers? I want you to practice all those skills, but sometimes, just being a good test taker, using test taking skills is really going to help you out a lot. So we want to practice those skills just as much as we want to practice our math skills, because that's part of life. So that's how I would approach this one. I do have practice problems for you for this one and a couple of the other ones that I went over. I'll send those out to you. I think if you can get those ones, if you got those ones on your own, then you should be good to go. Again, the post test is only 12 questions, 4 from each tile. Um, so I think most of you will do pretty good if you have these things that we went over down. We try to pair the practice questions that we went over pretty closely to the post-test questions. Again, we didn't go over all of it, but we definitely went over all the things you need to know for it, especially the vocabulary and the graphs and parent functions, domain, range, all that stuff. Um, let's see. Oh, the only thing, that I think. Okay, so let me wrap up this one. Is everyone okay, cool with this last question? This question 3 that I went over. Okay. Um, this is probably one of the harder ones you're going to get, just because you have to kind of create your equation from the information given. Miss Kajanis, do you have anything to add to this?
No, I just wanted to make sure that I wasn't confusing anybody. When you're trying to figure out the vertical shift, it's easier to look at the midline, like use it as a reference and the top of the wave, because sometimes they might stretch the wave
Mhm.
and then move it, and then that's when it gets confusing.
Okay.
But even when you vertically stretch it and like you're changing the amplitude, the midline is gonna stay the same unless you do a shift. Um, yeah, so that's all that I wanted to clear up, and it seems like now everything is all good.
Good. Okay.
Um,
Yeah, definitely use that midline. Sorry about that. Um,
Anything
yeah,
else?
I think that's it. As far as the questions, we're gonna hopefully this has been recorded and you guys can rewatch it and pause it when you need to. Take screenshots of the questions, um, and then take your post test. Like I said, you should really take your post test like as soon as possible, as soon as you're ready, and move on to Unit 3. And then contact us if you need help speeding up the pace a little bit, just because of we have 2.5 months, or actually 2 months left of school now. So
And yeah, and just for this unit, for some reason, just take a closer attention to the practice problems in the tutorial on the pages that Ms. Perez mentioned. Some of those problems are more similar to your post-its than the actual mastery test and practice problems. So if you need to go back and review a few of those, go ahead and do that. And the great thing about the tutorial practice problems is that if you are completely lost, you can always look at the answer and see if you can understand the answer and use those as notes. And all right, well, thank you for staying an extra 16 minutes. If you have any more specific questions, please let us know, and we'll make an appointment with you and go in more depth.
all right. Bye guys. Thanks
All right,
for
bye. Thank
participating.
you. Bye. Thank you for joining. Joining. Okay.